Good morning, students of class 9B. You are welcome in the period of mathematics. We have started new chapter circle. Today we will see some theorems and important rules and regulations of this chapter. So first is this note: as the length of a chord increases, its distance from the center decreases, and vice versa. As the length of a chord increases, this is length of the chord AB. AB is greater than chord CD. So this distance from the center is less than the distance of CD from the center. Mathematically, I have written here, if OM is smaller than ON, if OM is smaller than ON, then AB will be greater than, here will be greater than, if then AB will be greater than CD. So this distance OM is smaller than ON, so AB will be greater than CD. So it is written here, as the length of the chord increases, this is the length of the chord, it is increasing, means this is longer than CD. So this is the distance from center to chord is less than this distance from center to the chord. After that we have next theorem, theorem 3. A statement is one and only one circle can be drawn passing through three non-collinear points. These 3 points are non-collinear points. Non-collinear points means the points those do not lie in the straight line. These 3 points do not lie in the straight lines. Means if you see the example of collinear points, then this is the straight line. All these 3 points should lie in the same straight line. Then we say ABC are collinear points. But here these 3 points A, B and C do not lie in this type of straight line. So we say these A, B, C are non-collinear points. And as per statement, only one circle can be drawn through these 3 non-collinear points. Let us see. Given A, B and C, these 3 are the non-collinear points, and to prove one and only one circle can be drawn passing through these points. After that, I have done construction. AB and BC are joint. AB and BC are joint. Then in proof, what I have done? I have drawn the perpendicular bisector of AB and BC. So this line is the perpendicular bisector of AB and this line is the perpendicular bisector of BC. Both perpendicular bisectors are intersecting each other at point O. Here I have written also AB and BC are joined. Then in proof, perpendicular bisectors of AB and BC are drawn. AB and BC are drawn intersecting at point O, where if we join this AC and OB, then we get OA equal to OB equal to OC, that I have written. Now you consider the center of the circle and take the radius as OA and draw the circle. So that circle will pass through B and C. So we can say one and only one circle can be drawn through these 3 non-collinear points. Theorem 4. Equal chords of a circle are equidistant from the center. This is the theorem. Given informations are equal chords. So AB and CD, these 2 are equal chords. For that I have written in given information AB equal to CD. Then these 2 chords are equidistant from the center. Means distance from the center of AB is OM and distance from the center of CD is ON. It means if AB equal to CD, then OM equal to ON. This is asked to prove. To prove OM equal to ON. For that I have done construction. In construction, OA and OC are joint. Then proof in triangle OAM and OCN. These two triangles OAM and OCN. Our aim is to prove these two triangles are congruent. For that we need three conditions. Condition number 1. Given information is AB equal to CD. I divided both sides by 2. I got half of AB equal to half of CD, and half of AB is AM because this is the perpendicular bisector line drawn from the center to the chord is perpendicular bisector of the chord. So this line bisects the chord into two equal parts AM and BM. If AB equal to CD, then half of AB equal to half of CD, and half of AB is AM and half of CD is CN. Those two will also be equal. Condition number 2. As we know, line segment drawn from the center to the chord is perpendicular bisector. Property of bisector I have used already. Now I will use property of perpendicular. So this line is perpendicular to AB, here is 90 degree, and this line is perpendicular to CD, so here is also 90 degree. So angle AMO equal to angle CNO, that is equal to 90 degree. So both angles became equal. Reason is written here. OM is perpendicular to AB. OM is perpendicular to AB and ON is perpendicular to CD. For that, these two angles became equal and these two angles are equal to 90 degree. Third condition, OA and OC, these two are radii of the circle. So radii of the circle will be equal. For that I have written OA equal to OC, radii of the circle. So we got three conditions to say these two triangles are congruent. From which property? From RHS, right hypotenuse side. Right hypotenuse and side. Here also right means right angle, right hypotenuse and side. So these two triangles became congruent from RHS. So from CPCT we can say OM equal to ON. That was asked to prove. It means equal chords are equidistant from the center of the circle.